we're going to graph this parabola. We know it's a parabola on its side because it's an x equals the negative a value. So we know it's going to look like this. We have an a value of negative 1 over 8, an h value of 3, and a k value of 2. Finding a, h, and k first is generally the way to go about starting these. Is there a question about how I got those? Okay. So now that I have a, h, and k, I can find a vertex, an AOS, a focus, and a directrix. My vertex is the point hk, which is the point 3, 2. My focus, well, my AOS is also pretty easy. It's going to be the line y equals k, which is going to be y equals 2. The focus takes some calculating. I have to do this h plus 1 over 4a, comma k. Well, calculating h plus 1 over 4a, your calculator can handle that pretty well. H plus 1 over 4a. If you don't want to do it without your calculator, this isn't so bad. This is the same as 3 plus 1 over 4 times negative 8 over 1. Just do the reciprocal of whatever is in that little fraction there. That's what we worked on in our last chapter. It works out to 3 minus 2, which is 1. So the focus is the point 1 comma k, or 1 comma 2. And in your calculator, you just type it in as 3 plus 1 divided by, in parentheses, this all has to be in parentheses, 4 times negative 1 divided by 8. 3 plus 1 divided by 4 times negative 1 divided by 8, and that gives me the one that I found over here. So is there a question about how I found the focus? Any issue there? Okay, to find the directrix, that's the line x equals h minus 1 over 4a.
Why do you need to find directrix at all?
First of all, because I'm asking you to. But the directrix is going to be a quick and easy way to find 2 more points on our graph. And the directrix is sort of how you can frame the angle of your graph. Or the, yeah, I guess how the parabola points to the left. So h is 3 minus 1 over 4 times negative 1/8. Sometimes it's worth just calculating this all on its own. 1 over 4 minus 1/8. What a day. What a day. I'm going to go up here, and I can just change this plus to a minus. That's like one of the best things about these. I just take this plus and make it a minus. 3 minus 4 times 1 over negative 1 over 8, it's 5. So that is the line x equals 5. Now I can graph this. And I have a vertex at the point 3, 2. Go here. A focus at the point 1, 2. A directrix at the line x equals 5. This line right here. So there's my focus and there's my directrix. I'm not going to worry about the AOS. I mean, it's this line right here, y equals 2. I guess here I am worrying about it. That's not a big deal. But the key thing about graphing these now is I know that whatever the distance from the focus to the directrix is, in this case it was 1, 2, 3, 4. If that's 4, I can also go up 4 and down 4 from the focus. And these are 2 more points on my parabola. So my vertex is going to go through that point up there and through that point down there. And there is my parabola. Yeah.
What I was saying is, like, you know your focus and you know your vertex, so you can just find the distance between those
Oh,
two.
yeah, there's definitely other ways to find your directrix, yes. And an easy way would be just plot the first two you had, and then throw down the directrix, definitely. Yeah. Question there? Tyler, did your questions get answered? Okay. I'm going to write the equation of the problem with a vertex at 1, 4 and a focus at 1, 7. Well, this isn't necessary. You don't need to graph these, but it's much easier to do if you graph them. Oh, this graph's not going to work very well. That plane, I mean, let's grab this one. The vertex is at 1, 4. That's here. The focus is at 1, 7. That's here. So Max, where's the directrix?
1, 1.
The line y equals 1. This right here is our directrix. How did you know that?
Because it was just, I just used the,
3. So that must be 3 also. Alright,
exactly what I was going to say.
basically what you did.
Yeah.
Since that distance here from here to here is 3, then from here to here must also be 3, so you're just going to copy that down. Well, we don't need to graph this, but I'm just going to show how I can graph it very quickly now. This distance is 6, so I'm going to go 1, 2, 3, 4, 5, 6 over here. 1, 2, 3, 4, 5, 6 over here. And my parabola is going to look like this. And that might be useful for us later, depending on how you want to do this. We're trying to write the equation. What form is this equation going to be in? Y equals or x equals? Uh-huh.
Why?
Yeah, how do you know?
Because it's pointing up and not like to the side.
It's pointing up, not sideways. If it points up or down, it's a y equals. Left or right, it's an x equals. What do I know about this equation? And Alan? What's h? Well, h is 1, and when I plug it in, it becomes a negative 1. H is 1, k is 4, so now I have this. How do I find a? Uh-huh. Yeah, I can pick a point to plug in for x and y and solve for a. I cannot pick that point again. I've already used the vertex. You cannot plug back in the vertex to solve this. What's another point I could plug in?
Forward, 4, 5. Like,
I'm not sure if 4, 5 is actually on my graph. It's probably not. I mean, I drew this by hand, and all these points in this range, I'm not very sure of, because they were hand drawn. But there are 2 points I know for sure. Yeah, Mexley? This point right here is the point 7, 7. That point I know for sure is on my graph. So I can plug a 7 in for x, and a 7 in for y, and solve for a. I get that a equals 1 over 12. So my equation is y equals 1 over 12 x minus 1 squared plus 4. Question about that? Anybody tell me how else we could have found a?
You can plug in what you know into the directrix formula and then solve for
In this case, what is the directrix formula?
it. It's y equals k minus 1 over 4a.
And I know that the directrix has a y value of 1. This is the directrix is y equals 1. So I can plug a 1 in for this y. I already know that k is 4. And now I can solve this equation for a. So this is how you can do it without graphing. If you want to just do it algebraically, you've already got an h and k, algebraically find A with this method, and you're fine. Subtract a 4 from both sides. Multiply both sides by 4A. Divide both sides by negative 12. And you get your same 1 over 12 that we had before. So the graph isn't necessary, but it can sure help you know what you're looking at and what you're doing. Question there? Okay. The Chapter 9 quest is going to go in the third quarter grades. I know people in this class didn't get it finished because of Father Day taking so long to take attendance. This is going to go online, so I probably should have phrased that a little bit nicer. If you want to finish it, you can today during lunch. It's a block lunch with all the same lunch. If you want to come and get it done, you can. Otherwise, the way it is, it'll get graded and going. Today we're going to talk about circles. A circle is a set of all points equidistant from a given center. A circle is not just a round thing. It's very, very special. In fact, it's a very magical round thing. Some specific properties. The equation for a circle is fairly basic. The algebraic equation. If the center is on the origin, the center is at 0, 0, it's just x squared plus y squared equals r squared. But if the center is getting moved around at all, if the center is no longer on the origin, it's x minus h squared plus y minus k squared equals r squared. And h and k is your center. Just moves this stuff around. This is all on page 631 in your book. Oh, one thing that I really recommend, you're going to have a lot of formulas in this chapter, and a lot of formulas in Trig that comes next. Grab like a note card and write a formula down on it, and just have that for your homework. Because sometimes just have a little piece in front of you to just look at and refer to, instead of flipping back and forth between pages or trying to find it in your book or on your phone. I recommend just make little note cards for all these formulas. On quizzes and tests, I'll give them to you. But while you're doing your work, it's going to be worth your time to just make up a quick little note card to look over. I'm going to graph x squared plus y squared equals 25. 25 is my r squared. R squared is 25 in this problem. R stands for the radius. Well, if r squared is 25, then r is 5. Really, it's plus or minus 5 when I square root both sides. But plus or minus when you're going to count it for pretty well. And so to graph this, from my center, I'm going to go right 5, left 5, up 5, down 5. And then from there, you can try and draw a circle. And that one's pretty good, actually. In fact, let's see how good that is. While you're doing your homework, if you want to grab your compass that you've kept from geometry, you can draw a compass like I just did. And that circle's actually not quite so great. Let me show you a little trick that I came up with a few years ago that I'm real proud of. If I take my radius and divide it by the square root of 2, 5 divided by the square root of 2, that gives me 3.53. If I count 3.5 diagonals, so from here I go 1, 2, 3.5, 1, 2, 3.5, 1, 2, 3.5, and 1, 2, 3.5. If I count 3.5 diagonals, it'll give me 4 more points on my circle. Now it's going to be a little bit easier for me to try and get this thing to work out. Well, I did worse that time, I think. And there's my circle. Of course, you can just grab your compass. For the one on the right, where's my center? Yeah, Sabrina?
Oh,
no.
one.
The one on the right. It's going to get moved around. Yeah, Mitchell?
2, -3.
2, -3. Because there's these minuses in the formula, you do the opposite. 2, -3. So my center is now here. From that point, I have the same radius. My r is still going to be 5 because r squared is 25. So from this point, I'll go up 5. Right 5. Down 5. And left 5. And I've already calculated the 3.5 diagonals. Should be up here, actually. 1, 2, 3.5. 1, 2, 3.5.
And you made this trick?
I'm sure somebody else made it long before me, but nobody taught it to me. I figured it out one day. Pumped me up. I was amped. I was stoked. I think I'm drawing circles worse now than I was without that. Come on, Grant, you're embarrassing yourself. I am not a world circle drawing champion. Duh. Good so far? Find your center, find your radius, graph it. It's pretty simple. We're going to write the equation of this graph. All we really need to know is the center and the radius. What is the center? That's my h and my k. What's the radius? 3. So I'm going to do x minus 3 squared plus y minus 2 squared equals 3 squared. And it's x minus 3 squared plus y minus 2 squared equals 9. It's the equation of that circle on the right. Any question there? Sweet. The endpoints of a diameter are 5, 2, and 12, 6. We're going to write the circle's equation. We could graph this if we wanted to, but that wouldn't be super helpful. What do we really want to know about this circle? Yeah? Okay, how do I find that?
Why would we do that? Why would we just
Oh.
find the midpoint?
Okay, why the distance?
Because that gets you your diameter. Like that, like something else.
Okay, and then Max, what are you thinking?
Just find the midpoint, and then you have the center already.
Okay, but what's the radius?
I guess that's true.
Same these ones.
So you can use the distance formula from the radius from the center to the edge, or just from across the 2 edges. It doesn't matter. Let's just find the midpoint first, because we know we need that either way. So that's x1 plus x2 over 2, comma, y1 plus y2 over 2. We've talked about having a programming party, right? You can't have the distance and midpoint formulas in your calculator unless you have programmed them, and unless you know how to program them. By that I mean that you don't just like look at a video online and copy the buttons they tell you to push. I want you to know how to do it. But if you want to program these midpoint and distance formulas into your calculator, please go for it. And so I think next week sometime I'm going to have a programming party. Those are the type of parties that I throw. You know, people tend to come to those in force. So if you want to sit down, I'll kind of teach you how to program in general, and you can program these things into your grapher. That'd be fine. So I do 5 plus 12 divided by 2, comma, 2 plus 6 divided by 2, and that gives me 8.5, comma, 4. That is the center, which means that that's h and that's k. Now I've got to find the radius. Well, I think if I'm going to do the distance formula, I might as well do the distance from one point to the center. So the distance formula is going to be the square root of 12 minus 8.5 squared plus 6 minus 4 squared, which is the square root of 3.5 squared plus 2 squared, which is this. Square root of 3.5 squared plus 4. 16.25, I think. Oh. Oh, if I didn't square root it, it would have been 14.03. Yeah, 16.25 first. Let me do this. 3.5 squared plus 2 squared. 16.25. If I actually calculate that square root, the radius is 4.03. That's about what my radius is. So I found the distance from the center to one of the edges. That distance is my radius. So what's the equation going to be?
Let's use x minus 8.5 squared plus 5 minus 4 squared equals 16 and 4.
Yeah, what I'm hoping you recognize here is we don't actually have to go through the process of calculating the square root and actually finding the radius, because we're just going to square it anyways when we put it back into the formula. It's just going to get squared anyways. So really that is the number that we need in order to find what number goes there. Question on that. Okay, my yawn count has tripled in the last 2 minutes in this class. So we're going to do, I think, one more problem, and then I'll give you some time to work. And we'll come back and learn about ellipses after that. I'm going to graph this equation. This is the equation of a circle. Problem is, I don't really know anything about it. I don't know where the center is, I don't know the radius, I don't know nothing. So what I'm going to do is group up the x's, group up the y's, and get rid of the thing that doesn't have a variable. I added 3 to both sides. And I'm going to complete the square twice. I'm going to complete the square with these two. I'm going to complete the square with these two. Whatever I add to one side, I add to the other. Is there any question how I did those two pieces there? It's all b over 2 squared. Like if b is negative 6, b over 2 is negative 3, then b over 2 squared is 9. So now when I complete the square, I get x minus 3 squared plus y plus 2 squared equals 16. So the center of this circle is at 3, negative 2. The radius is 4. Then I'll do my little 4 divided by root 2 trick to get my diagonals. If I do 4 divided by the square root of 2, that's 2.83. So if I go 2.8 diagonals, 1, 2.8, 1, 2.8, 1, 2.8, and 1, 2.8. That is my circle. Ugh. It's making me sick. I was doing so well yesterday. There you go. Questions there at all? Complete the square twice. By completing the square steps over here. The circle completing the squares are pretty easy because the a values are going to be 1. Why don't you get to work and I will check off the rest of your homework. We probably won't finish ellipses, but we'll get started. An ellipse. Can you tell me what an ellipse is?
Ellipse is or ellipse is?
What an ellipse is. Anybody? You always describe it as an oval, but there's actually something pretty special about ellipses. First of all, an ellipse is the path that planets follow when they orbit. Gravity pulls things in orbits with ellipses. If I take any point and randomly put it on the edge of this ellipse, so this point can slide around my ellipse. And if I make this segment here, I make this segment here, and I measure both of these lengths. That length is 6.78. That length is 10.14. And if I take those lengths and I add them up, if I do that length plus that length, it's 16.92. And as I move this point over here, the length of AB will get shorter, but the length of BC will get longer, and the length of the two added up won't change. It's 16.92 wherever it goes. That's what an ellipse is. An ellipse is all the points that have the same combined distance from two focuses. That's a focus. That's a focus. And this is the last time you'll hear me say the word focuses. It's foci with a soft C. Foci. The plural of focus is foci. An ellipse is all the points that have the same cumulative distance between two foci. If you take the distance between the two foci and add them up, it's the same. It doesn't change. It's a constant. And if you move the foci farther apart, the ellipse gets more eccentric, meaning more narrow on one end. If you move the foci closer and closer together, it gets more and more circular. In fact, if the focus is on top, do this here. If the foci fall on top of each other, you have a perfect circle. And with one that I've built here, if I pull this and I go so extreme, yeah, it kind of breaks. That's called the hyperbola. We'll learn about those in a couple days. And yes, at some point is a line. A line is part of the definition. A line can fit in an elliptic definition. I try and do pictures on our website that sort of fit what we're doing. What we're doing right now is called conic sections. This is called a double napped cone, meaning there's two cones stacked on top of each other with lines passing through each other. And if you pull a section out of this cone and look at the section you pull out, you can get a lot of different things. If the section you pull out is parallel to the base of the cone, the thing you pull out is a circle. If the section you pull out is perpendicular to the base of the cone, what you pull out is a hyperbola. And hyperbola is what we graphed last chapter, like 1 over 4, 1 over x is a hyperbola. If the thing you pull out is at an angle passing between this angle here and the base, that's an ellipse. And if the thing you pull out is an angle like so, that section is a parabola. And you can also get lines, and you can also get points, and you can also get anything you really need in geometry or algebra can come from a cone. They're all conic sections. Just kind of mind-blowing. It is. So, and then each of these conic sections has like very, very useful things. We talked about how a parabola is like the dish that collects all the signals from a satellite. And the ellipse is what does orbits, among some other things. So we're going to talk about how to graph ellipses today. Ellipses have a lot of information to worry about. The formulas look like so: x squared over a squared plus y squared over b squared, or y squared over a squared plus x squared over b squared, both equal to 1. Again, these will be online. You can, I recommend if you're going to write these down, write them down on a note card instead of on a sheet of paper, but whatever you want to do. If my center is right here, if that's my center, put a C there for center. the distance to the farthest point on the ellipse, the farthest point away from the center, is called a vertex. And there's two vertices on this ellipse. Every ellipse has two vertices. The closest point to the center is called the co-vertex. And every ellipse has two co-vertices. And then the foci are next to the vertices. Not the co-vertices, but the vertices. The foci are closest to the farthest points. This ellipse here has a horizontal orientation, meaning it's stretched more sideways than vertically. This ellipse here has a vertical orientation, meaning it's stretched more up and down than it is sideways. Question about any of those so far? I'll talk about what all this means in a second. Okay, I think it's over here. That's what I want. An ellipse has a major axis and a minor axis. The major axis right now is the blue line, the one that's traveling the longest distance, in this case the horizontal distance. What is the length of this major axis I have up here? What is the length of that blue segment? Okay, how about this?
Is it
Yeah, go ahead, Max.
it's 3 times the co-vertex?
Um,
Sorry, is the minor axis, is it 3 times the minor axis?
it is not. No, because this could be stretched, Right now it might kind of look like that, but it can be stretched to where that's clearly not the case, either direction. You see what I mean?
Mm-hmm.
Yeah. What did you say, Sabrina?
Didn't it say just 2 times the distance from the vertex to the center?
Correct. It's 2 times the distance from the vertex to the center. What's the distance from the vertex to the center?
0.
That makes no sense, Trevor. Come on, people, look at this like a little bit more closely. If this has a value of a, from 0 to a is a. The distance from the center to this vertex is a units. So the total distance across is 2a. Okay, the length of the major axis is 2a. What's the length of the minor axis? 2b. That's what this and this are saying. The length of the major axis is 2a, the length of the minor axis is 2b.
This is only for when the middle is, the center of it is 0, 0?
It doesn't matter. The center will get moved around, but those things won't change a whole lot. We'll see tomorrow really how they change. But that's still not going to change much. The length will still always be 2a and 2b.
Right, so it'll always be equal distance from
The center.
But what about when you change it, how you move it and then change the shape? Will it still be the same?
It'll still be the same. Yeah, because as it changes on one side, when I made this, the center isn't fixed. This doesn't have a fixed center. So the center's going to move as I pull this. The center's moving. Like right now the center's here, and now the center's here. But it's still the same distance between the two foci, and therefore it's the same distance between the two vertices and co-vertices. Yes, the center's always in the middle of everything. Circles and ellipses and hyperbolas are very symmetric. There's all kinds of symmetries going on. The vertices are at 0a and 0 negative a. The a0 and negative a0 if it matters. The co-vertices are at b and the foci are at c. Any more? Don't. Just pull this up. Skip you. We just talked about that. We'll come back to that. We are going to graph using, this is the formula for when the center gets moved around. If the center gets moved, there's just a minus h and a minus k. It's nothing new. H and k is the new center. We have centers at hk, but we still travel distances of 2a and of a and b from the center. So we are going to find A, B, C, H, and K in this equation. A, B, C, H, and K. I haven't talked a lot about C yet. It was on the last slide. We haven't talked about it. We will. Right now, the most important thing to remember about ellipses and also hyperbolas when we get there, the most important thing to remember is that A is bigger than B. A is always going to be the bigger denominator. So right now, A squared is not this 4, even though it looks like it should be the 4. A squared is 49. We're really doing this one right here, because the A value is underneath the Y. Yeah?
You didn't get us these formulas.
Yeah. Have I not said that enough, Max? I think I've only said it like 7 or 8 times, but
Just making sure.
now we're at 8 or 9. Got it. So if A squared is 49, what's A? Yeah. A squared is 49, and A is 7. What's B squared? B squared is 4, so B is 2. H is 2, K is -1. For the purpose of graphing this, we're not going to have to find C. What C tells you is the distance from the center to the foci. The C right here tells me the distance from the center to the foci. C is found by using this formula. It's the Pythagorean theorem, but with a minus instead of a plus. A squared minus B squared. So over here I have C squared equals A squared minus B squared, which means that down here C squared equals 49 minus 4, which means that C squared equals 45, which means that C equals the square root of 45, which is 3 root 5. You simplify that. A third root of 5, 3 root 5. So now I can graph. Since the bigger value comes underneath the Y letter, since the bigger value comes underneath this Y, I know that my ellipse is going to have a vertical orientation. It's going to be angled or squeezed upwards. So from my center, and my center is at 2, -1, from my center here, I'm going to go up 7 and down 7. That's my A value, because A is 7. My B value is 2, so I'm going to go right 2 and left 2. That gives me my ellipse. Find a center, find an A in a couple distances, and you've got it. Now the foci comes from this C value, 3 root 5. I'm going to actually calculate that, because I don't know how to graph that as a radical. I do 3 times the square root of 5, or the square root of 45 is the same thing. It's 6.7. So I'm going to go up 6.7, 1, 2, 3, 4, 5, 6.7, and down 6.7, 1, 2, 3, 4, 5, 6.7, and there's my 2 foci, the plural of focus. And if I want to get fancy, that's how it should look. That's the correct ellipse then. Thank you. Question about that? this. An ellipse has a center at 0, 2, a focus at 6, 2, and a vertex at 8, 2. Write the equation of the ellipse and graph it. Well, I'm just going to plot what I have. The center is at 0, 2. The focus is at 6, 2. And the vertex is at 8, 2. And Max is right, I know the other focus. If this distance here is 6, then this distance here, 1, 2, 3, 4, 5, 6, that's my other foci. And I got 2 more, that's my other vertex. So I at least know that this axis is horizontal. This ellipse has a horizontal orientation. Everything with ellipses is going to come down to c squared equals a squared minus b squared. Everything comes down to that one right there. So I have c squared equals a squared minus b squared. Which of these do I know? A, B, and C. Which of those do I know? What's C?
It's
That C was for center, not for the value of C. Sorry, that C was for center. Does anybody remember what C gives us? What C represents?
the distance between the center and the focus.
Center and the focus.
So it's 6.
So C is 6. Which letter gave us the distance from the center to the vertex? A. A was the distance from the center to the vertex. So my A value is 8. So I have 36 equals 64 minus b squared, which means that negative 28 equals b squared equals negative b squared, which means that 28 equals b squared, which means that the square root of 28 equals b, which is 5.3. So b is about equal to 5.3, meaning from my center, I'm going to go up 5.3 and down 5.3. Now I have co-vertices. And now I have an ellipse. That top one was too high, but it'll work. Go here to there. That's how it should have looked, more or less. A's, B's, and C's. A is the distance from center to vertex, B is from center to co-vertex, C from center to foci. So now what's the equation of this graph? We're using the formula x squared over a squared plus y squared over b squared equals 1. How do I know it's x over a and not y over a?
Hold on, though.
Okay.
Wouldn't it be, don't you need to get the K's and H's in there? Because the center
Oh,
is
yep.
different.
Hold on there. K's and H's. Good. How do I know that it's x over a and not y over a?
It's well horizontal.
It's going horizontal. Okay, my center was 0, 2. So it's x squared plus y minus 2 squared. My a value was 8, so a squared is 64. My b value was 6, so b squared is 36. And that equals 1. That's the equation of that ellipse. I've been asked by a lot of people, how can I graph x equals in my calculator for those parabolas? Or probably, how could I graph something like this in my calculator to do an ellipse or a circle or something? I'm going to make that extra credit. If you can figure out how to graph a circle, how to graph a parabola on its side, or how to graph an ellipse in your calculator, I will give you extra points. The key to it really is, how can your grapher, what's the only thing your grapher can graph? Yeah? Y equals. So you can just get the y by itself, you can graph this. You can solve this for y, you can graph it. I'm not saying that's easy, but I'm saying that's how you can do it. Any other questions? We will do much more of this tomorrow. This is kind of to get us started. You should continue working.